Hello students, today we will learn about operators in Java. In the previous lesson you have learned how to declare and initialize variables. Whereas now you will learn how to use them in programming using operators to perform arithmetic and logical operations. Operators are symbols that perform specific operations on operands. Operands are data values involved in the operation. The operands of an operator are always evaluated from left to right. They can be variables or constants. An operator needs one or more operands to perform any operation. The valid combination of both operands and operators make an expression which returns a computed result. Let us understand this through an example. Algebraic expression. Operands x into 4 equals to 32. Operators. In the above mentioned expression, x into 4 equals to 32, x, 4 and 32 are operands, whereas asterisk and equal to are operators. In the previous lesson, we have already discussed the major categories of operators. Now let us discuss these operators in detail. Java operators can be classified as unary, binary or ternary. Unary operator operates on only one operand. Example, -n, ++n, -n. The element is n. Binary operator operates on two operand values. Example, a plus b. The elements are a and b. Ternary operator operates on three elements for its operation. It is also known as conditional operator because the value assigned to a variable depends upon a condition. Syntax: variable equals to condition question mark test expression 1 colon test expression 2. C equals to bracket in A is greater than B bracket close question mark A colon B semicolon. Before moving forward, let us first discuss about arithmetic operators. Arithmetic operators are used to perform basic mathematical calculations, that is, addition, subtraction, multiplication, division and remainder. Each of these operators are considered as binary arithmetic operators because they require two operands to perform calculations. An arithmetical expression may include variables, constants, and arithmetical operators to give a meaningful result. Apart from these operators, Java provides two unary arithmetical operators that work on single operand. These operators are further categorized as unary plus. The operator unary plus is written before the operand. This operator results in the same value of the variable. For example, if a is equal to 10, then plus a means 10. If a is equal to -5, then plus a means -5. If a is equal to 0, then plus a means 0. Okay, students, note that the value without plus operator is also treated as positive value by default. Unary minus. The operator unary minus also precedes an operand. This operator inverts the value of an operand, that is, if an operand is the positive value, it converts the value of that operand to its negative value, and vice versa. Let us take an example. If a is equal to 10, then minus a means -10. If a is equal to -5, then minus a means 5. If a equals to 0, then minus a means 0. Alright, let us talk about increment or decrement operators. Increment and decrement operators are used to increase or decrease the value stored in a variable by 1, respectively. Using these operators, we can write the expressions x equals to x plus 1 as x plus plus and x equals to x minus 1 as x minus minus. The increment and decrement operators can be used both as prefix and suffix. We can make use of these operators in the following manner. Prefix increment plus plus x. When an increment operator precedes its operand, it is known as prefix increment. It increases the value of operand by 1 and then evaluates the expression. Prefix decrement minus minus x. It decreases the value of operand by 1 and then evaluates the expression. Postfix increment x plus plus. When an increment operator follows its operand, it is known as postfix increment. It evaluates the expression and then increases the value of operand by 1. Postfix decrement. X minus minus. It evaluates the expression and then decreases the value of operand by 1. Let us understand the working of increment and decrement operators with the help of following examples. Suppose y equals to 5 semicolon. Working of prefix increment. If y equals to plus plus y into 2. Working of postfix increment. If y equals to y plus plus into 2. Working of prefix decrement. If y is equal to minus minus y into 2. Working of postfix decrement. If y equals to y minus minus into 2. Give the output of prefix increment and decrement. 1. A equals to 9 semicolon. A equals to plus plus a by 5 semicolon. A is increased by 1 and then divided by 5. A equals to 10 by 5 semicolon. A equals to 2 semicolon. Hence the final value of A is 2. Number 2. A equals to 9 semicolon. A equals to minus minus A into 5 semicolon. A is decreased by 1 and then multiplied by 5. A equals to 8 into 5 semicolon. A equals to 40 semicolon. Hence the final value of A is 40. Give the output of postfix increment and decrement. 1. A equals to 10 semicolon. A equals to A plus plus slash 5 semicolon. A remains 10 before division. That is, A is equal to 10 divided by 5. A equals to 2 semicolon. Hence the final value of A is 2. 2. A equals to 10 semicolon. A equals to A minus minus into 5 semicolon. A remains 10 before multiplication. That is, A equals to 10 into 5. A equals to 50 semicolon. Hence the final value of A will be 50. Let us understand this through an example. Create a program to demonstrate the use of unary operators. Class unary arithmetic. Curly braces in public static void main string args. Curly braces in int A equals to 20 result semicolon. Variables are declared. Result equals to plus A semicolon. System.out.println result semicolon. Result is still 20. Result equals to minus A semicolon. System.out.println result semicolon. Result is now minus 20. Result equals to plus plus A semicolon. System.out.println result semicolon. Result is now 21. Result equals to minus minus A semicolon. System.out.println result semicolon. Result is now 20. Result equals to A plus plus semicolon. System.out.println result semicolon. Result is now 20. Result equals to A minus minus semicolon. System.out.println result semicolon. Result is now 21. Curly braces close, curly braces close. Let us understand binary arithmetic operators. Operators that act upon two operands are known as binary arithmetic operators. They are defined as follows. Operator, addition, symbols, plus, format, A plus B. Description. This operator is used to add two operands. The operands can be integer, byte, short, long, etc. If they are strings, they will be concatenated. Result, if A equals to 12, B equals to 4. 16. Subtraction, minus, A minus B. This operator is used to subtract the value of one operand from another. 8. Multiplication, asterisk, A into B. This operator is used to multiply the value of two operands. 48. Division, A divided by B. This operator is used to divide the value of one operand with the value of another operand and find the quotient. 3. Modulus, percentage, A percentage B. This operator is used to find the remainder of a division. 0. Example. Create a program to demonstrate the use of arithmetic binary operators. Class arithmetic operators, curly braces in public static void main string args, bracket close, curly braces in, int a equals to 20, b equals to 10, semicolon. Variables are declared and initialized. Integer result, semicolon. Result equals to a plus b, semicolon. System.out.println, bracket and result, bracket close, semicolon. Result after addition will be displayed as 30. Result equals to a minus b, semicolon. System.out.println, result, semicolon. After subtraction, the result will be displayed as 10. Result equals to a into b, semicolon. System.out.println, result, semicolon. After multiplication, the result will be displayed as 200. Result equals to a divided by b, semicolon. System.out.println, result, semicolon. After division, the result will be displayed as 2. Result equals to a percentage b, semicolon. System.out.println, result, semicolon. After modulus, the result will be displayed as 0. Curly braces close, curly braces close. Give the output for the following statements. Number 1, number 2, number 3, number 4. Students, let us learn about assignment operators. Assignment operator is used to assign a value to a variable or constant. It assigns a value on its right side to the variable written to the left of it. Let us understand this through some examples. Variable equals to expression. Age equals to 23, semicolon. Salary equals to 40,000, semicolon. In the given example, 23 and 40,000 are the numeric values which are assigned to the variables age and salary respectively. Int a, b, c, semicolon. A equals to 5, semicolon. B equals to 3, semicolon. C equals to a plus b, semicolon. In the statement, the value of a plus b is assigned to the variable c. C equals to c into 3, semicolon. In the statement, the value stored in C is further multiplied to 3 and assigned to C. If we try to assign a new value to an operand which already contains some value, then the existing value will be replaced by the new one. For example, a equals to 10, b equals to 20, semicolon. If we write an expression a equals to b, semicolon, then the value stored in a, that is 10, will be overwritten by b, that is 20. Java provides 5 arithmetic assignment operators which are used for all the arithmetic and binary operators. It offers special shorthand assignment operators that simplify the coding of certain type of assignment statements. Shorthand assignment operators. Let us talk about relational operators. Relational operators are used to show the relationship among the operands. These operators compare the values of variables and determine the result in the Boolean expression, either true or false. Java provides 6 types of relational operators. Operator, greater than, symbols, format, a is greater than b. Result, if a is equal to 12, b is equal to 4. True, less than. A is less than b. False, greater than or equal to. A is greater than or equal to b. True, less than or equal to. A is less than equal to b. False, equal to. A equal to b. False, not equal to. A not equal to b. True. Example, create a program to demonstrate the use of relational operators. Class relational operators, curly braces in, public static void main, bracket in, string args, bracket close, curly braces in, int variable 1 equals to 16, semicolon, int variable 2 equals to 40, semicolon. System.out.println, bracket in, double quote and result, colon, if variable 1 is equal to 16 and variable 2 is equal to 14, double quote close, bracket close, semicolon. System.out.println bracket and double quote in variable 1 is greater than variable 2 is colon double quote close plus bracket in variable 1 is greater than variable 2 bracket close semicolon. System.out.println bracket and double quote in variable 1 is smaller than variable 2 is colon double quote close plus bracket in variable 1 is smaller than variable 2 bracket close semicolon. System.out.println bracket and double quote in variable 1 is greater than equal to variable 2 is colon double quote close plus bracket in variable 1 is greater than equal to variable 2 bracket close semicolon. System.out.println bracket and double quote in variable 1 is smaller than equal to variable 2 is colon double quote close plus bracket in variable 1 is smaller than equal to variable 2 bracket close semicolon. System.out.println bracket and double quote in variable 1 is equal to variable 2 is colon double quote close plus bracket in variable 1 is equal to variable 2 bracket close semicolon. System.out.println bracket in double quote in variable 1 is not equal to variable 2 is colon double quote close plus bracket in variable 1 is not equal to variable 2 bracket close semicolon. Curly braces close. Okay, students, note that the relational operators have a lower precedence than the arithmetic operators, but a higher precedence than the assignment operators. For example, a plus b not equal to c into c plus d into d, semicolon. Bracket in a plus b bracket close not equal to bracket in c into c bracket close plus bracket in d into d bracket close semicolon. In the above mentioned expression, a plus b and c into c plus d into d are evaluated before the relational operator not equal to is evaluated. Let us discuss about logical operators. Java uses logical operators to construct complex decision-making expressions. They give result in the form of true or false depending upon the outcome of different relational expressions. Logical operators are further categorized as logical and operator. The logical and written as and is a binary operator that compares the result of two relational expressions. It returns true if both the expressions are evaluated to true, else it returns false. For example, a equals to 9 semicolon b equals to 20 semicolon. A is greater than b bracket close and bracket in a is smaller than b bracket close. This will return false because one of the expressions between them is false. However, if we compare an expression, bracket in a is smaller than b bracket close and bracket in b is greater than a bracket close, the answer will be true as both the expressions are true. Let us see the results of an and operator for various expressions. Expression 5 is greater than 3 and 15 is smaller than 25. Result true. Reason both expressions are true. 15 is greater than equal to 15 and 20 is smaller than 16. False. Second expression is false. 25 is equal to 20 and 50 is greater than 30. False. First expression is false. 18 not equal to 18 and 50 equal to 60. False. Both expressions are false. Logical OR operator. The logical OR is a binary operator which needs two relational expressions as operands. The logical OR operator returns true if either of the two conditions evaluates to true, otherwise it returns false. Let us take an example. A equals to 9, B equals to 20 semicolon. B is greater than A, B is smaller than A. This will return true because first expression is true. Let us see the results of logical OR operator for various expressions. Expression 5 is greater than 8, 35 is smaller than 25. False. Both expressions are false. 28 is greater than 28, 20 is smaller than 16. True. First expression is true. 30 is equal to 20. 45 is greater than 20. True. Second expression is true. 13 is not equal to 23. 30 is equal to 30. True. Both expressions are true. Logical not operator. The logical not operator is a unary operator which deals with only one operand, relational expression. The logical not operator reverses the result of the expression following it. That is, if the expression returns true, then not operator returns false. For example, A is equal to 9, B is equal to 20, semicolon. Not equal to, A is greater than B. This will return true. Let us understand the working of logical not operator with the following expressions. Expression not 5 greater than 8. Result true. Reason 5 is greater than 8 is false. Not bracket in 21 is greater than equal to 15 bracket close. False bracket in 21 greater than equal to 15 bracket close is true. Students note, precedence of logical operators is not and or. That is, if a statement contains all the three logical operators, then not will be evaluated before any other logical operator. Example 4. Create a program to demonstrate the use of logical operators. Class logical operators. Curly braces in, public static void main, bracket and string args, bracket close. Curly braces in, int variable 1 equals to 11, semicolon. Int variable 2 equals to 12, semicolon. Character ch equals to single quote in a, single quote close, semicolon. System.out.println bracket in variable 1 equals to 11 bracket close and bracket in variable 2 equals to 13 bracket close semicolon. The result will be false as one of the conditions between them is false. System.out.println bracket in variable 1 is greater than variable 2 or bracket in variable 2 equal to 12 bracket close semicolon. The result will be true as one of the conditions is being satisfied. System.out.println bracket in not bracket in variable 1 is greater than variable 2 bracket close semicolon. The result will be true. Curly braces close, curly braces close. Let us learn about bitwise operators. Bitwise operators are special types of operators which perform manipulations on binary data bits. These operators are used for addition, multiplication, shifting and negating the binary data. These are also called binary operators as they are based on Boolean algebra, that is 0 or 1, where 0 indicates false and 1 indicates true. They work only with byte, short, integer and long type operands. Real and float type values are not allowed. Java provides 4 bitwise operators which are as follows. Operators and, meaning bitwise and, bitwise or, bitwise or, bitwise complement, bitwise and. This operator returns the value 1 true if the corresponding bit in both operands is 1. Otherwise, the resulting bit is 0. The working of AND operator works similar to binary multiplication. In general, when you multiply any number with 0, then it will always result as 0. Likewise, AND operator returns 0 if one of the bit is 0. For example, A equals to 3, B equals to 5, semicolon. Binary value of A equals to 0, 0, 1, 1. Binary value of B equals to 0, 1, 0, 1. Logical AND operation is equal to 0, 0, 0, 1. Hence, decimal equivalent of result is 1. Bitwise OR. This operator returns the value 1 true if either of the two bits in both operands is 1. For example, A equals to 3, B equals to 5, semicolon. Binary value of A equals to 0, 0, 1, 1. Binary value of B equals to 0, 1, 0, 1. Logical OR operation is equal to 0, 1, 1, 1. Hence, decimal equivalent of 0, 1, 1, 1 is 7. Bitwise OR, also known as exclusive OR. This operator returns the value 1 true if the two operands bits are different. Otherwise, the result is 0. For example, A equals to 3, B equals to 5, semicolon. Binary value of A equals to 0, 0, 1, 1. Binary value of B equals to 0, 1, 0, 1. Logical XOR operation equals to 0, 1, 1, 0. Hence, A complement B is 0, 1, 1, 0 and the decimal equivalent of result is 6. Bitwise complement. This is a unary operator. The complement operator inverts the value of each bit in an operand. That is, if the operand bit is 1, the result will be 0. For example, A equals to 2, semicolon. Binary value of 2 is equal to 1, 0. Bitwise complement operator equals to 0, 1. Hence, bitwise complement A is 0, 1 and the decimal equivalent of result is 1. Predict the output for the following codes. Number 1, A equals to 35, B equals to 46, semicolon. Hence, bracket in A and B, bracket close, equals to 34. Binary value of 35 is equal to 1, 0, 0, 0, 1, 1. Binary value of 46 is equal to 1, 0, 1, 1, 1, 0. Logical AND operation is equal to 1, 0, 0, 0, 1, 0. Decimal equivalent of the result is equal to 34. Number 2, A equals to 25, B equals to 23, semicolon. Hence, comma, bracket in A or B, bracket close, is equal to 31. Binary value of 25 is equal to 1, 1, 0, 0, 1. Binary value of 23 is equal to 1, 0, 1, 1, 1. Logical OR operation is equal to 1, 1, 1, 1, 1. Decimal equivalent of the result is equal to 31. Number 3, A equals to 7, B equals to 2. Hence, comma, bracket in A, bitwise complement B, bracket close, is equal to 5. Binary value of 7 is equal to 0, 0, 1, 1, 1. Binary value of 2 is equal to 0, 0, 0, 1, 0. Logical XOR operation is equal to 0, 0, 1, 0, 1. Decimal equivalent of the result is equal to 5. 4. A equals to 7, semicolon. Hence, comma, bracket in bitwise complement A, bracket close, is equal to 8. Binary value of 7 is equal to 0, 1, 1, 1. Logical complement operation is equal to 1, 0, 0, 0. Decimal equivalent of the result is equal to 8. Example. Create a program to demonstrate the use of bitwise operators. Class bitwise operator, curly braces in, public static void main, bracket in string args, bracket close, curly braces in, int A equals to 11, semicolon, int B equals to 12, semicolon, int result, semicolon, result equals to A and B, semicolon, system.out.println, bracket in result, bracket close, semicolon, result of 11 and 12 is 8. Result equals to A bitwise or B, semicolon. System.out.println, bracket in result, bracket close, semicolon. Result of 11 bitwise or 12 is 15. Result equals to A bitwise complement B, semicolon. System.out.println, bracket in result, bracket close, semicolon. Result of 11 bitwise complement 12 is 7. Result is equal to bitwise complement A, semicolon. System.out.println, bracket in result, bracket close, semicolon. Result of complement 12 is minus 12. Curly braces close, curly braces close. Let us learn about ternary operator, conditional operator. The ternary operator, question mark, colon, is also known as conditional operator. The operator needs 3 operands to perform an operation. Syntax: variable equals to test expression, question mark, expression 1, expression 2. Here test expression 1 is evaluated first. If it evaluates to true, then the variable contains the expression 1. Otherwise, it will accept the value of the expression 2. In a single line of code, the Java ternary operator allows you to assign a value to a variable based on Boolean expressions. At its most basic, the ternary operator can be used as an alternative to if-else control structure. But if it goes beyond that, it can then be used on the right-hand side of Java statements. For example, int a equals to 5, b equals to 20, c semicolon. C equals to a greater than b question mark, a colon b semicolon. Here the value 20 is stored in the variable c as the test expression a greater than b is false. Expression 6 is greater than 4 question mark 9 is to 7. Result 9. Reason 6 is greater than 4 is true. 12 smaller than 4 question mark 1 is to 0. 0. 12 is smaller than 4 is false. 2 greater than 9 question mark 4 is to 3. 3. 2 is greater than 9 false. Examples: create a program to demonstrate the use of the conditional operator. Class conditional operator, curly braces in, public static void main bracket in string args bracket close, curly braces in, int a equals to 3 semicolon, int b equals to 10 semicolon, int c semicolon, c equals to a is greater than b question mark, a plus b colon b minus a semicolon. If the test expression a is greater than b returns true, then the expression a plus b will be evaluated and the result will be stored in variable c. Otherwise, the expression a minus b will be evaluated and the result will be stored in the variable c. System.out.println bracket in c bracket close semicolon, curly braces close, curly braces close. Rewrite the following snippet using ternary operators. Number 1. If bracket in a is greater than b bracket close, curly braces in c equals to bracket in a into b bracket close semicolon, curly braces close, else curly braces in c equals to bracket in b divided by a bracket close semicolon, curly braces close. Statement colon c equals to bracket in a is greater than b bracket close question mark bracket in a into b bracket close colon bracket in b divided by a bracket close semicolon. If bracket in salary is greater than equal to 20,000 bracket close, curly braces in bonus equals to 5% semicolon, curly braces close. Else curly braces in bonus equals to 2% semicolon, curly braces close. Statement bonus equals to bracket in salary greater than equal to 20,000 bracket close question mark bracket in 5% bracket close colon bracket in 2% bracket close semicolon. If bracket in marks are greater than equal to 89 divided by 100 bracket close, marks greater than equal to 89%, curly braces in grade equals to A1 semicolon, curly braces close, else curly braces in grade equals to B1 semicolon, curly braces close. Statement colon grade equals to bracket in marks greater than equal to 89 by 100 bracket close question mark bracket in A1 bracket close colon bracket in B1 bracket close semicolon. Alright students, let us understand precedence of operators. In mathematics, solving an expression with one operator is very simple. For example, 30 plus 20 is equal to 50. But if we have more than one operator in the entire expression, then how can we evaluate the overall value of the expression? In such cases, we use the rule of BOD-MAS to evaluate the precedence of operators. For example, 30 plus 20 into 10 is equal to 30 plus bracket in 20 into 10 bracket close is equal to 30 plus 200 is equal to 230. Similarly, in Java, when an expression contains more than one operator, we use the rule of BOD-MAS to evaluate the precedence of operators. It decides the order in which different operators in an expression are evaluated. Precedence, lower precedence, higher precedence, operator, type, parenthesis, array subscript, member selection, associativity, left to right, unary post increment, unary post decrement, right to left, unary pre-increment, unary pre-decrement, unary plus, unary minus, unary logical negation, unary bitwise complement, unary typecast, right to left. Multiplication, division, modulus, addition, left to right. Subtraction, bitwise left shift, left to right. Bitwise right shift with sign extension. Bitwise right shift with 0 extension. Relational less than. Relational less than or equal, left to right. Relational greater than. Relational greater than or equal. Type comparison object only. Relational is equal to, left to right. Relational is not equal to, left to right. Bitwise and, left to right. Bitwise exclusive or, left to right. Bitwise inclusive or, left to right. Logical and, left to right. Logical or, left to right. Ternary conditional, right to left. Assignment, addition assignment, subtraction assignment, multiplication assignment, division assignment, modulus assignment, right to left. Let us learn about expressions. An expression is composed of one or more operands and returns a value as a result. It may consist of constants, variables, functions, return values and operators. An expression can be mathematical, relational or logical, or it could be a compound expression depending upon the result it produces. Arithmetic expression. An arithmetic expression may include variables, constants and arithmetical operators to give a meaningful result. For example, average equals to total marks divided by number of subjects, semicolon. The above mentioned expression is an arithmetic expression. It will store the result of the division into the variable average. An arithmetic expression is further categorized into pure arithmetic expressions and mixed arithmetic expressions. Pure arithmetic expressions, an expression that has all operands of same data types. These expressions can be pure integer expressions or pure real expressions. Pure integer expression will contain only integer values. If a and b are two integer variables, then number 1 b equals to bracket in a into 5 bracket close. Number 2 a equals to a into plus b. Number 3 b minus bracket in a into 2 bracket close. An expression that contains only real constants and or real variables using arithmetic operators is known as real arithmetic expression. If m and n are two floating variables, then number 1 m divided by n, number 2 m into n minus 2.67, number 3 m plus bracket in n into 1.4 bracket close will be considered as real arithmetic expressions. Mixed arithmetic expression. If an expression contains both integer and real values, then it is known as mixed arithmetic expression. For example, float pi equals to 3.14 semicolon. int radius equals to 3 semicolon. Double area of circle equals to pi into radius semicolon. Boolean expression. Expressions that result into true or false are called Boolean expressions. Boolean expressions are valid combinations of constants, variables, relational and logical operators. Number 1, int a equals to 20, int b equals to 10 semicolon. Boolean c equals to a is greater than b question mark true colon false semicolon. Number 2, when score is equal to 100 question mark double quote in excellent double quote close colon double quote in good double quote close semicolon. String a equals to bracket in score equal to 100 bracket close question mark double quote in excellent double quote close colon double quote in good double quote close semicolon. Students, let us understand how to understand about accepting arguments through the main method. Arguments are the values that are assigned to a method or function as input. The process of assigning values to a method is called passing arguments. The output of the method or function is based upon these inputs. While executing a program through its main method, we can design the program to accept some arguments from the user. This can be achieved if we pass a variable as an argument to the main method. For example, Create a program that will accept the temperature as an argument in Celsius and convert it into Fahrenheit. Create a new project and add a new class to it. Write the code as shown in the following screenshot. Compile the program and execute it through its main method. You will now see the method call dialog box. Enter the value of temperature in the provided space and click OK button. The program will execute and display the result on the terminal window. Example: create a program that will accept the amount in US dollars and convert it into rupees. Assume that $1 equals to rupees 62.80. Public class currency, curly braces in, public static void main bracket in int US underscore dollar bracket close, curly braces in, double in underscore rupee semicolon, in underscore rupee equals to US underscore dollar into 62.80 semicolon. System.out.println bracket in double quote in US dollar double quote close plus US underscore dollar plus double quote in equals to rupees double quote close plus in underscore rupees plus double quote in bracket in at US dollar 1 equals to rupees 62.80 bracket close double quote close bracket close semicolon. Curly braces close, curly braces close. Example: create a program that will accept the distance covered by a cab and calculate the total bill. The 1 kilometer will be charged at rupees 20 and each consequent kilometer will be charged at rupees 17.50 per kilometer. Public class cab, curly braces in, public static void main bracket in float distance bracket close, curly braces in, int amount semicolon. Amount equals to bracket in int bracket close bracket in 20 plus bracket in 17.5 into bracket in distance minus 1 bracket close semicolon. System.out.println bracket in double quote in distance traveled equals to double quote close plus distance plus double quote in kilometers double quote close bracket close semicolon. System.out.println bracket in double quote in please pay rupees double quote close plus amount plus double quote in slash minus double quote close bracket close semicolon. System.out.print bracket in double quote in thanks for choosing Himachal cab services full stop double quote close bracket close semicolon. System.out.println bracket in double quote in for further cab queries please call 011-8888-9999 double quote close bracket close semicolon. Curly braces close, curly braces close. Example: create a program that will accept the salary of an employee and add 15% increment to it. Public class salary, curly braces in, public static void main bracket in int salary bracket close, curly braces in, int new underscore salary semicolon. New underscore salary equals to salary plus bracket in salary into 15 by 100 bracket close semicolon. System.out.println bracket in double quote in old salary colon rupees double quote close plus salary bracket close semicolon. System.out.println bracket in double quote in new salary colon rupees double quote close plus new underscore salary bracket close semicolon. Curly braces close, curly braces close. Example: a tour and travel company is organizing a picnic for your school. The students will commute through mini buses, each having a seating capacity of 25 students. Create a program that will accept the number of students and display the minimum number of cabs required. It will also display the number of students sitting in the last cab. public class picnic, curly braces in, public static void main bracket in int students bracket close, curly braces in int cap semicolon, int students underscore left semicolon, caps equals to students by 25 semicolon, students underscore left equals to students percentage 25 semicolon, system.out.println bracket in double quote in, number of caps required colon double quote close plus bracket in caps plus 1 bracket close semicolon, system.out.println bracket in double quote in students in last cap colon double quote close plus students underscore left bracket close semicolon, curly braces close, curly braces close. Students, let us take a quick quiz. Which delimiter is used to represent the string literal in a program? Let me tell you about math class. Math class is a very important class in Java. Just like the string class, math class also has many functions that help us in solving mathematical problems. Let us understand the important methods of math class. Square, argument double, return type double. This function accepts a double value as argument and returns the square root of it. Pow, argument two double values, return type double. This function returns x raised to yx. It accepts two double values as arguments. The first argument is considered as the base and the second argument works like the index to find the power value. Students, let us know more. All methods of the math class are static, meaning they are invoked through the class name. Random, argument nil, return type double. This function is used to get a random real value between 0 and 1. It does not accept any argument. Whenever this function is called, it returns a real value between 0 and 1, such as 0.33, 0.78, 0.1, etc. Max, argument two double values. This function can also work with an integer, long and float arguments. Return type double. This function accepts two double values and compares them to find the greater one. It returns the greater value among the two. Minimum, argument double value. This function can also work with integer, long and float arguments. Return type double. This function accepts two double values and compares them to find the smaller one. It returns the smaller value among the two. Abs, argument double value, return type double. This function accepts one double value as argument and returns its absolute value. If the number is positive, it is returned as it is. If it is negative, then the positive number is returned. Let us create a program using abs main function that will display the absolute value of a number passed to it. R integer, argument double value, return type integer. This function accepts a double value and returns the integer value that is closest to it. Sin, argument double value, return type double. This function accepts a double value that represents an angle in radians. It returns the sine value of the passed argument. Cell, argument double value, return type double. This function accepts a double value and returns the integer value that falls after it. It returns the result in double format. Floor, argument double value, return type double. This function accepts a double value and returns the integer value that falls before it. It returns the integer in double format. Cos, argument double value, return type double. This function accepts a double value that represents an angle in radians. It returns the cosine value of the passed argument. Tan, argument double value, return type double. This function accepts a double value that represents an angle in radians. It returns the tangent value of the passed argument. Log main, argument double value, return type double. This function accepts a double value as argument and returns its natural logarithmic value. Rest of the functions are as given in the following table. Functions: a sine bracket in y bracket close action. This function returns the angle whose sine is y. Example: math.asine bracket in 6 bracket close a cos bracket in y bracket close. This function returns the angle whose cosine is y. Math.acos bracket in 6 bracket close a tan bracket in y bracket close. This function returns the angle whose tangent is y. Math.atan bracket in 6 bracket close a tan 2 bracket in x comma y bracket close. This function returns the angle whose tangent is x or y. Math.atan 2 bracket in 2 3 bracket close exp x. This function returns e raised to x. Math.exp 4 round x returns the rounded values up to the nearest integer. Math.round 5. Let us learn about errors in Java program. Errors are small mistakes that affect the output of a program. In big organizations, every program or application is designed to solve a real-life problem. But if the program contains errors, it can lead to wrong results or sometimes no results at all. At times, we confuse ourselves between errors and bugs. A bug is a flaw in a program due to which something works incorrectly. On the other hand, an error is a flaw or mistake when the program does not work at all. However, these definitions are quite fluid and depend mostly on the context. The process of removing bugs is called debugging. Programming errors can be divided into three major categories. Syntax errors. Syntax errors prevent the program from getting executed. These errors are caused due to mistakes that you make while typing the code. Some mistakes can be wrongly written keywords, forgetting necessary punctuation, writing incomplete statements, etc. At the time of compilation, the compiler converts the programming statements into machine-level code. During this process, if the compiler finds a piece of code that it does not understand, it generates an error. Therefore, in simple language, you can say that the errors caused due to the incorrect programming statements are known as syntax errors. Some common syntax errors are missing semicolon, wrong punctuation, misspelled keyword, missing braces, use of those variables which have not been declared in the program, using a variable without assigning any value to it. Let us understand this through an example. int a, b, colon. The above mentioned statement will produce syntax error as a statement is terminated with colon rather than with semicolon /. Logical errors. Before writing a piece of code, a good programmer always designs a programming logic in his mind. If the design logic is incorrect, it may lead to wrong output. Such errors are called logical errors. The programs with logical errors may get compiled and executed, but such programs may not give the desired output. Some common logical errors are use of a wrong or incorrect formula, an error in algorithm, or even the wrong selection of an algorithm. Let us understand key concept. Logical operators can be used to construct sophisticated conditions. Consider the following code. For example, speed equals to distance divided by time, bracket in correct logic, bracket close. Speed equals to time divided by distance, incorrect logic applied. Result an unexpected output. Hence, logical error is the result of an incorrect logic applied by the programmer. Runtime errors. Java runtime errors are those errors that occur during the execution of a program due to some illegal operations performed in the program. Examples of some illegal operations that may produce runtime errors are dividing a number by 0, trying to open a file which is not created, lack of free memory space. Alright students, let me tell you about data type conversion. Data type conversion is the process of changing one data type into another. The most important feature of data type conversion is to prevent data loss while dealing with expressions containing multiple data types. Suppose you have a jar filled with juice and an empty glass. If you want to shift the juice from a jar, either you have to take a jar of the same size or some bigger vessel. But if you try to shift the juice in a glass, you will lose some amount due to the smaller size of the glass. Likewise, while doing data conversion, you cannot pour an integer full of stuff into a bite-sized container because this way data will be lost. You want to evaluate an expression having operands of different data types. Data type conversion helps us to convert all data into a single data type and then evaluate the expression. Let us see an example. K equals to I by j. If I equals to 8.0 and j equals to 5.0, then the result is 1.6. Since k is an integer type variable, the result stored is 1 instead of 1.6. This is how the data is lost if we do not choose the correct data type. Luckily, in Java, we can easily convert the data type depending upon our requirement. The data type conversion can be done in two ways: implicit type conversion, explicit type conversion, typecasting. Implicit type conversion. In implicit type conversion, data types of various operands are automatically converted by the compiler. Implicit type conversion converts data types of all the operands to the largest data type present in the expression. Let us sort the various data types in an ascending order depending on the amount of memory needed. In an expression contains values of different data types, then the results of each operation are evaluated in such a way that the data type of the result is of the higher data type, higher of the two. Let us understand the concept of implicit type conversion with the help of the following expression. Example: int I equals to 12 semicolon, float f equals to 3.9 f semicolon, double d equals to 4.2 comma dg semicolon, long L equals to 3 semicolon, dg equals to d plus f minus I divided by L semicolon. In the above mentioned statement, expression I divided by L will be evaluated first, that is, an integer is going to be divided by a long. The result will be a long 4. The second expression could be d plus f. A double 4.2 is being added to a float 3.9 and the result will be a double 8.1. Finally, the long 4 will be subtracted from the double 8.1 and it will result in the double 4.1. So the final result, double 4.1, will be stored in the double variable dg. Let us know more. The automatic conversion of one data type into another data type is sometimes known as conversion. Explicit type conversion, typecasting. The automatic type conversions are helpful, but they do not fulfill the user requirements completely. For example, if you want to assign an integer value to a byte variable, the conversion will not be performed automatically because the byte data type is smaller in size than integer. Such kinds of conversions are done forcefully by a programmer and are called explicit type conversions or typecasting. Syntax: variable 1 equals to new data type, variable 2 semicolon. For example, float a semicolon, int b semicolon, b equals to bracket in int bracket close a semicolon. In the above mentioned statements, you want to assign the value stored in variable a to the variable b. B is an integer type variable while a is a float type variable. Hence, you are forcibly trying to convert the data type of the variable a from float to integer. You already know that integers do not have fractional components. Thus, when we assign a float type value to an integer type variable, the fractional component is lost. Since such kinds of conversions are forcefully done by the programmer, so he is fully aware of the changes in the output of a program. Although in the above mentioned program you observe a loss of data, fractional component, yet sometimes you are willing to perform such operations. Time for fact file. Java follows a well-defined set of precedence rules that governs the order in which operators will be evaluated in an expression. For example, to understand the need of explicit conversions in real-life scenarios, let us take an example of a billing machine at a grocery shop. Create a billing program which may return a fractional value after adding taxes and deducting applicable discounts. Suppose the bill amount is Rs 546.78. For this bill, a user can pay Rs 546, considering that the payment of 78 paise is an unfeasible job. You want that the program should display the payable amount as a whole number, that is Rs 546 only. Hence, to convert the fractional value to an integer value, you will forcefully convert the float type data to the integer type data. The same can also be obtained by using C, flow or int methods of the math class. Example: let us create a program to demonstrate the use of explicit data conversion. This program will accept the bill amount as a floating value and return the payable amount as a whole number. Let us understand system.out.print statement. To get the output on the screen, we use system.out.print bracket in double quote in any text double quote close or variable bracket close semicolon, or system.out.println bracket in double quote in any text double quote close or variable bracket close semicolon. System.out represents monitor screen and print or println is the method that prints the given text on the screen. The difference between print and println is small but important. The println method prints the information sent to it, then moves the cursor to the beginning of the next line. The print method is similar to println but does not advance to the next line when completed. Alright, let us discuss about getting input from keyboard. It is often useful to design a program to input data from the user interactively during execution. In this manner, new results can be computed each time the program is run, depending on the data that is entered. To input data from the user, Java provides scanner class, which is a part of the standard Java class library, java.util.scanner. It provides convenient methods for reading input values of various types. To use scanner class, write the following import statement at the top of your program. Import java.util.scanner semicolon. Next, in your program code, create an object of the scanner class. Scanner sc equals to new scanner bracket in system.in bracket close semicolon. This declaration creates a variable by using a new operator that represents a scanner object. You can use any name for the object as desired. The scanner accepts a parameter that indicates the source of the input. The system.in object represents the standard input stream, which by default is the keyboard. Next, use the following methods to get the inputs of various data types as given in the list. String next, parenthesis. To input a single character or word, stops input when space is encountered. String next line, parenthesis. To input a line of character string, that is a sentence, stops input when enter key is pressed. Boolean next boolean, parenthesis. To input a boolean value, byte next byte, parenthesis. To input a byte value, double next double, parenthesis. To input a double value, float next float, parenthesis. To input a float value, int next int, parenthesis. To input an integer value, long next long, parenthesis. To input a long integer long value, short next short, parenthesis. To input a short integer short value. To input an integer, system.out.println bracket in double quote and enter an integer value colon double quote close bracket close semicolon. Intn equals to sc.next int parenthesis semicolon. To input a double, system.out.println bracket in double quote and enter a double value colon double quote close bracket close semicolon. Double d equals to sc.next double parenthesis semicolon. To input a string, system.out.println bracket in double quote and enter a single word colon double quote close bracket close semicolon. String word equals to sc.next parenthesis semicolon. System.out.println bracket in double quote and enter a sentence colon double quote close bracket close semicolon. String line equals to sc.next line parenthesis semicolon. Okay students, let us now do some programming practice. Example: write a Java program in which you input two numbers and find the sum and product of the two numbers. Import java.util.scanner semicolon. Public class sum prod. Curly braces in public static void main bracket in string args bracket close curly braces in. Scanner sc equals to new scanner bracket in system dot in bracket close semicolon. int number 1 comma number 2 comma sum comma product semicolon. System dot out dot print ln bracket in double quote in enter two numbers colon double quote close bracket close semicolon. Number 1 equals to sc dot next int main semicolon. Number 2 equals to sc dot next int main semicolon. Sum equals to number 1 plus number 2 semicolon. Product equals to number 1 into number 2 semicolon. System dot out dot print ln bracket in double quote in sum is colon double quote close plus sum bracket close semicolon. System dot out dot print ln bracket in double quote in product is colon double quote close plus product bracket close semicolon. Curly braces close, curly braces close. Example. Write a Java program in which you input radius of the circle and find the area and circumference of the circle. Import java.util.scanner semicolon. Public class circle. Curly braces in. Public static void main bracket in string args bracket close. Curly braces in. Scanner sc equals to new scanner bracket in system dot in bracket close semicolon. Double radius comma area comma circumference semicolon. Final double pi equals to 3.14 semicolon. System dot out dot print ln bracket in double quote in enter radius of the circle colon double quote close bracket close semicolon. Radius equals to sc dot next double main semicolon. Area equals to pi into radius semicolon. Circumference equals to 2 into pi into radius semicolon. System dot out dot print ln bracket in double quote in area of the circle is colon double quote close plus area bracket close semicolon. System dot out dot print ln bracket in double quote in circumference of the circle is colon double quote close plus circum bracket close semicolon. Curly braces close, curly braces close. Example. Write a program to input temperature in degrees Fahrenheit and convert to degrees centigrade. Import java.util.scanner semicolon. Public class temp convert. Curly braces in. Public static void main bracket in string args bracket close curly braces in. Scanner sc equals to new scanner bracket in system dot in bracket close semicolon. Double Fahrenheit comma cen semicolon. System dot out dot print ln bracket and double quote in enter temperature in degrees Fahrenheit colon double quote close bracket close semicolon. Fahrenheit equals to sc dot next double main semicolon. Centigrade equals to 5.0/9.0 into bracket in Fahrenheit minus 32 bracket close semicolon. System dot out dot print ln bracket in double quote in temperature in degrees centigrade colon double quote close plus centigrade bracket close semicolon. Curly braces close, curly braces close. Example. Input student name, comma, class, comma, roll number and marks in 5 subjects. Calculate the total marks in percentage and display the same. Import java.util.scanner semicolon. Public class total marks. Curly braces in. Public static void main bracket in string args bracket close curly braces in. Scanner sc equals to new scanner bracket in system dot in bracket close semicolon. String s name comma class semicolon. int roll number, comma, marks 1, comma, marks 2, comma, marks 3, comma, marks 4, comma, marks 5, comma, d marks, semicolon. Double percentage, semicolon. System.out.println bracket in double quote in enter student's name, colon, double quote, close bracket, close, semicolon. S name equal to sc dot next line main, semicolon. System.out.println bracket in double quote in enter student class, colon, double quote, close bracket, close, semicolon. Class equals to sc dot next main, semicolon. System.out.println bracket in double quote in enter student roll number, colon, double quote, close bracket, close, semicolon. Roll number equals to sc next int main, semicolon. System.out.println bracket in double quote in enter marks in 5 subject, colon, double quote, close bracket, close, semicolon. Marks 1 equal to sc dot next int main, semicolon. Marks 2 equal to sc next int main, semicolon. Marks 3 equals to sc dot next int main, semicolon. Marks 4 equals to sc next int main, semicolon. Marks 5 equals to sc next int main, semicolon. Total marks equals to marks 1 plus marks 2 plus marks 3 plus marks 4 plus marks 5, semicolon. Percentage equals to bracket in total marks into 100 bracket close divided by 500, semicolon. System.out.println bracket in double quote in total marks obtained, colon, double quote, close, plus total marks bracket close, semicolon. System.out.println bracket in double quote in percentage, colon, double quote, close, plus percentage bracket close, semicolon. Curly braces close, curly braces close. Examples: input employee name and basic salary. Calculate the following. HRA at 15% of basic salary, DA at 70% of the basic salary, TA at 2% of the basic salary, PF at 10% of the basic salary. Find the net pay equals to basic salary plus HRA plus DA plus TA minus PF. Import java.util.scanner, semicolon. Public class employee, curly braces in, public static void main bracket in string args bracket close curly braces in, scanner sc equals to new scanner bracket in system dot in bracket close semicolon, string employee name, double B salary, comma HRA, comma DA, comma TA, comma PF, comma net pay, semicolon. System.out.println bracket and double quote and enter employee name, colon, double quote, close bracket close, semicolon. Employee name equals to sc next line main, semicolon. System.out.println bracket and double quote and enter basic salary, colon, double quote, close bracket close, semicolon. Basic salary equals to sc dot next double main, semicolon. HRA equals to 0.15 into basic salary, semicolon. DA equals to 0.70 into basic salary, semicolon. TA equals to 0.02 into basic salary, semicolon. PF equals to 0.10 into basic salary, semicolon. Net pay equals to basic salary plus HRA plus DA plus TA minus PF, semicolon. System.out.println bracket and double quote in employee name, colon, double quote, close, plus employee name bracket close, semicolon. System.out.println bracket and double quote in basic salary, colon, double quote, close, plus basic salary bracket close, semicolon. System.out.println bracket and double quote in house rent allowance, colon, double quote, close, plus HRA bracket close, semicolon. System.out.println bracket and double quote in dearness allowance, colon, double quote, close, plus DA bracket close, semicolon. System.out.println bracket and double quote in traveling allowance, colon, double quote, close, plus TA bracket close, semicolon. System.out.println bracket and double quote in provident fund, colon, double quote, close, plus PF bracket close, semicolon. System.out.println bracket and double quote in net salary, colon, double quote, close, plus net pay bracket close, semicolon. Curly braces close, curly braces close. Example, input item name, rate and quantity sold. Calculate the amount rate into quantity at 12.5% as VAT and display the net bill. Import java.util.scanner, semicolon, public class item, curly braces in public static void main, bracket in string args bracket close, curly braces in scanner sc equals to new scanner, bracket in system.in bracket close semicolon, string item name semicolon, double rate comma amount comma VAT comma n bill semicolon, int quantity semicolon, system.out.println bracket and double quote in enter item name colon double quote close bracket close semicolon, item name equals to sc.next lines, system.out.println bracket and double quote in enter rate colon double quote close bracket close semicolon, rate equals to sc.next double main semicolon, system.out.println bracket and double quote in enter quantity sold colon double quote close bracket close semicolon, quantity equals to sc.next lnt main semicolon, amount equals to rate into quantity semicolon, VAT equals to 12.5 by 100.0 into amount semicolon, n bill equals to amount plus VAT semicolon, system.out.println bracket and double quote in item name colon double quote close plus item name bracket close semicolon, system.out.println bracket and double quote in rate colon double quote close plus rate bracket close semicolon, system.out.println bracket and double quote in quantity sold colon double quote close plus quantity bracket close semicolon, system.out.println bracket and double quote in bill amount colon double quote close plus amount bracket close semicolon, system.out.println bracket and double quote in VAT colon double quote close plus VAT bracket close semicolon, system.out.println bracket and double quote in net bill colon double quote close plus n bill bracket close semicolon, curly braces close, curly braces close. Example, input principal rate and time. Calculate the simple interest and compound interest. Import java.util.scanner, semicolon, public class interest, curly braces in public static void main, bracket in string args bracket close, curly braces in scanner sc equals to new scanner, bracket in system.in bracket close semicolon, double p comma r comma t comma si comma ci semicolon, system.out.println bracket and double quote in enter principal amount colon double quote close bracket close semicolon, p equals to sc.next double main semicolon, system.out.println bracket and double quote in enter rate of interest colon double quote close bracket close semicolon, r equals to sc next double main semicolon, system.out.println bracket in double quote in enter time colon double quote close bracket close semicolon, t equals to sc next double main semicolon, si equals to bracket in p into r into t bracket close divided by 100 semicolon, ci equals to p into math power bracket in 1 plus r divided by 100 bracket close comma t bracket close minus p semicolon, system.out.println bracket in double quote in simple interest colon double quote close plus si bracket close semicolon, system.out.println bracket in double quote in compound interest colon double quote close plus ci bracket close semicolon, curly braces close, curly braces close. Example, input 3 sides of a triangle and find the area using Heron's formula. Import java.util.scanner, semicolon. public class area, curly braces in, public static void main, bracket and string, args, bracket close, curly braces in, scanner SC equals to new scanner, bracket and system dot in, bracket close, semicolon, double side 1, comma side 2, comma side 3, comma S, comma area, semicolon, system.out.println, bracket and double quote in, enter 3 sides of triangle, colon, double quote close, bracket close, semicolon, side 1 equals to SC dot next double main, semicolon, side 2 equals to SC dot next double main, semicolon, side 3 equals to SC dot next double main, semicolon, S equals to bracket in, side 1 plus side 2 plus side 3, bracket close, slash 2, semicolon, area equals to math dot square T, bracket in S into, bracket in S minus side 1, bracket close, into, bracket in S minus side 2, bracket close, into, bracket in S minus side 3, bracket close, semicolon. System.out.println, bracket and double quote in, area of triangle is, colon, double quote close, plus area, bracket close, semicolon, curly braces close, curly braces close. Let us go through the points at a glance of this chapter. Operators are the symbols that perform specific operations on operands. Java operators can be classified as unary, binary or ternary, which are further categorized into arithmetic operators, increment, decrement operators, relational operators, logical operators, bitwise operators, assignment and conditional operator. Precedence of operators decides the order in which different operators in an expression are evaluated. Arguments are the values that are assigned to a method or function as input. An expression is a valid collection of operators, constants, and variables which returns a result. Errors are small mistakes that affect the output of a program. An arithmetical expression may include variables, constants, and arithmetical operators to give a meaningful result. Expressions that result into true or false are called Boolean expressions. Syntax errors are caused due to mistakes while typing the code. Logical error is a result of an incorrect logic applied by the programmer. Runtime errors occur during the execution of a program due to some illegal operation performed in the program. Data type conversion is the process of changing one data type into another. Implicit type conversion converts data types of all operands to the largest data types present in the expression. Conversions which are done forcefully by a programmer are called explicit type conversions or typecasting. System.out.println statement places the cursor on the next line after printing the text. System.out.print statement keeps the cursor on the same line.